Because I have a meeting this afternoon, so when I finish, I will send you guys a message. Tonight. Tonight is Halloween party.
Yeah, so is it Halloween party?
那个小胖叫一下。
No.
老邓没过来啊。
他们没过来。
啊。
我就是放假吧。你有本事把我那点掉啊。
I saw Sean. Last Facebook. Last Saturday. Last Saturday, I met him on the road. He was on the way to go party.
Oh, with
No, not yet.
那个加斯梅，把这个放你旁边那个座位上，放。
哎呀，
开开了是吗？啊，红色。这样吗？这样吗？啊？这就看不到啊。这样吗？
因为我现在用的是黑轴的，打字用，我跟你说，开宇最贵的就是打字用那个叫做室友，就是你的室友，如果没听到的话，第二天就想把你给杀了。
好了。
我看这个门有那种拖的。好，还有个17磅。这个跟你好像差不多。电池其实是一样的。然后17.99磅是什么鬼 ？iPad， 我看一下，我这个是 Air 级的。因为我也有这个问题，它有个设置，在哪？
不是，我开了也连不上。我这个我还是会的，还是要忽略了重连一下。而且连4G也要8分。
这么好。就是你重连了，它很快自动断条是吧？
不是，它就是不能用。
那你可能要用 VPN， 因为我们有一个它接触不了那个用 VPN。哎，我操！
下去就可以。
哎，我怎么看它这个是 iPad？ 我后面开个毛，刚买，是国内的时候我都不知道怎么开。 怎么看？就是怎么看这个是猎还是什么法师？因为他的这个是可以做的。当好，我记得你直接是 AS 的，你直接下面那个。对啊，可不这个大多了，好大。没有。他有的卖，那个是13年的。哎，不对，我这个是 mini 的，它是 A，这是mini，因为 mini 的也有这种。
安迪，那个万代必须是买票的那个人，不能去领。
然后他这 AS 他妈20年。
我2点下课，要不我下课找你，我把那个票领了。
算，下面那个越看越恐怖，越看越恐怖。写好了。我要叫人有长带，但是我这个也要有点长。
里面有一本是要80欧币，
那你要发那个天亮灯吗？
对啊。
还有有一台旧的，我要台是专门用来做而且一分 ES 的那种东西。
你去吗？你去海山吗？
不敢用这台电脑。
我说你要去的还是？
因为我国内自己有一台电脑。
这个嘛。
你要是去的还是海上，然后再
还有一堆这种 IDE 的那种放上去，可能要100多 G。然后我那台电脑还上不下。
其实我不太想去，我今天喝了2-3天的酒，我就头好晕。明天上午
我要不要剁手？
我们今天不是还要讨论？
好想剁手吗？这个 Rachel 是短头发。是哪的话，我记得好像。
Okay. Sorry I'm a little late. Got held up in the previous meeting. Okay, so brief recap on how we got here. Last week I started off by revisiting Nelson's definition of hypertext, and then took a long jump back into the past, looking at knowledge organisation systems. And at the end of last lecture, I just about got back to Ted Nelson, who is a lovely, slightly eccentric chap. Nelson is primarily known for having quote invented unquote hypertext, although as you will have seen from the previous lecture, he didn't so much invent something, rather he named it. Hypertext had already existed in things like Vannevar Bush's Menace, and something that Ted actually does very much credit. Also, for that matter, things like Doug Engelbart's NLS had hyperlinks in, and very much what Ted did was to talk about the name for those things. Now, the paper in which he coined the term hypertext is one that was presented back in 1965, and it has a very unpromising title, A File Structure for the Complex, the Changing and the Indeterminate. And just to give you a rough idea, this is one of the figures from this paper, and this hopefully brings it back to this idea that hypertext, as Nelson conceives it, is all about knowledge management. It's all about trying to structure personal information, organizational information, trying to help, typically, as he saw it, help scholars. So we have this view trying to show how this file system, which is effectively a way of recording data with hyperlinks in, could be used to tie together different types of thing in what he calls total filing. So the example here was of something being used by a historian, in which you have several different things. There's a manuscript which they're currently writing, and the historian is able to tie this in together with all of the other information that they're using to generate this. Sorry, yeah.
Sorry, is it possible to just move the projection across slides so that's just
no, I can't, unless you want to go on the desk and get back to it. No, I think you're in the cheap seats with limited visibility. Yeah. There is plenty of space at the back. Whether you can see clearly from there is another matter. The slides are online, so you could follow them from there if you wanted. Moving forward a little bit into the mid-70s, another one of the influential books that Nelson wrote was actually, well, it's two books in one, Computer, Lib and Dream Machines, and they're sort of printed back to front, so you can sort of turn the book either way and see a different book. What's interesting is that there are two different, effectively it is two completely different books that have been tied together. Computer Lib is sort of picking up where Engelbart left off, trying to explain to people what computers are and how they could use computers. Dream Machines is where he first properly explained what his vision of a hypertext system to enable people to manage data was going to look like. And this system in here was a thing he called Xanadu. Now, a brief aside, Xanadu is both a really great name for a hypertext project and at the same time an extremely bad name for a hypertext project. Back into the tail end of the 18th century, we have this chap, Samuel Taylor Coleridge, who, amongst other things, is famous for writing a poem called Kubla Khan about the Mongol warlord. And it starts off like this in Xanadu de Kubla Khan. Having talked to Ted about this, actually, Xanadu comes from two places as far as he's concerned. Part of it is a reference to, explicitly to this poem, also part of it is a reference to one of his favourite films, to Citizen Kane. This poem famously was never finished. The poet was interrupted by a visitor from a neighbouring town. Well, basically, the story goes he had a laudanum enhanced drink, he'd taken some drugs, he fell asleep, and when he woke up he had this poem in his head. He started writing it down and was interrupted before he could finish writing it all down, so forgot the rest. Possibly the most famous unfinished poem in history, even if the story is a little bit wonky. Project Xanadu, Ted's Ted's hypertext system, has famously been called the longest running vaporware story in the history of the computer industry. That was from an article in Wired magazine back in the mid-90s. Project Xanadu, he started calling it by this in about 1960, and his ideas of hypertext evolved around it. In the 70s he started getting money to develop it. In the 80s, so he'd had a demo version in 1972. In the 80s he got quite a lot of money from Autodesk, who produced AutoCAD, to build this system. they never actually produced a working system after the best part of 2.5 decades. In the middle of this, there's another book that he published, a thing called Literary Machines, published in 1980 for the first time. We've got some copies of that in the library, and that goes far more into what he saw as the technical underpinnings of this system, Xanadu. So he explains things like the data structures and the protocols that are required. It's very interesting to look at the design of Xanadu and compare that to the design of the web. There are some places in which they're very similar and some places in which they're very, very different indeed. As far as TED is concerned, Project Xanadu is something that is still ongoing, and there have been various people that have tried to build sort of open source versions of Xanadu. As it was, he took the source code and open sourced it in 1998. You should still be able to find it online if you're interested in looking at 18-year-old, very poorly documented source code. Now, Ted's never been one for sort of holding back, so all of this was bound together. He had this view of a mission statement, and this was one of the best descriptions of what it was he was trying to do with Xanadu. Deep interconnection with intercomparison and reuse. As he said, since 1960, he fought for a world of digital electronic documents with side-by-side intercomparison, so being able to take two versions of the same document and compare them and see where the differences are. Frictionless reuse of copyrighted material. Amongst his claims is that he invented the notion of a micropayment. Today's popular software simulates paper. Never get Ted started on PDF. Terrible thing, as far as he's concerned. The World Wide Web, another imitation of paper, trivializes our original hypertext model with one-way, ever-breaking links and no management of versional content. We fight on. It's less a statement of intent than a political manifesto. But we can pick through Xanadu and say, well, what actually were the key ideas in this that he was particularly keen about? So, if you have two different documents or documents that are generated from each other, how can you compare them? So can you see the differences between them? Does the system help you investigate those? Some things the web has certainly done, worldwide publishing without barriers. Other things the web doesn't do, links that don't break. Ted was very keen that when a link is written, the link should not break, or rather if the link breaks it should not be visible to the user. So there should be no 404 error in Xanadu. All of the documents provided on Xanadu should be versioned, so it should be possible for you to go back and see the history of a document, see how it was edited, how it came into being. This clearly isn't the case on the web as a whole, but you can look at things like Wikipedia, and there are certainly things like that in Wikipedia. Another idea is this notion of transclusion. So his idea of transclusion is of, rather than copying text from one place to another, so let's say I'm writing a paper, I want to quote another paper, rather than just cut and pasting that text, in my document I should include a pointer to this other document, so when a person reads this, that other document is seamlessly incorporated into mine, or the section of that one is seamlessly incorporated into mine. And tied up with this is the notion of what he called trans-copyright. So the idea that there would be a system of micropayments that readers would pay when reading documents, but also if they're reading a document that transcludes part of another document, the author of the transcluded document receives some payments as well. And bearing in mind most of these ideas were in place by about 1980, a lot of this is very prescient, and with the ongoing conversations about copyright online, these are far more interesting now than they were then, or far more relevant now than they were then. I mentioned that in 1972 he had a demo version. Here's a photograph of the demo version, or rather, this is a photo of a mock-up of the demo version, trying to show, links between documents, being able to compare things. There are actually bits of white tape on a computer screen because they hadn't quite got it working at the time they wrote the paper. There's a lot of smoke and mirrors in this. Other people subsequently have written versions, so this was a version that's written in about 2006, 2007. So here we have a sort of a very fancy 3D interface whereby we can look at a particular document and see where particular pieces of text here came from. So for example, here is a piece of text which is transcluded from this other document here, and the idea is you can get some sort of visualization, so you can do concordancing and see how a document was generated. Nelson is not overly keen on the web. One of the sore points is that people keep saying, yes, the web, that was what you were talking about all those years ago. As he says, the Xanadu project did not fail to invent HTML. HTML is what we were trying to prevent. Ever-breaking links, links going out with only quotes you can't follow to their origins, no version management, no rights management. Okay. What I want to do now, between now and the end of the lecture, is to give you a sort of a whistle-stop tour of the hypertext systems that were built after Ted coined the term hypertext and before the invention of the web. So I'm going to go up to the invention of the web pretty much. Because it's very easy when you look at histories of hypertext to assume that, well, if you get beyond, and then there was the web, it's very easy to look at it and say, well, there was Memex, and then there was Xanadu that was never completed, and then the web was the first proper hypertext system. And in fact, there's a very long history of these things. So back in the late 60s, and in fact this was a project that Nelson was involved with, Brown University developed this thing called HES, the Hypertext Editing System. This actually went into production. This was used in part for managing documentation for the Apollo program at NASA. So here you have a hypertext system, a proper hypertext system. You notice they haven't quite started using the newfangled mouse that Doug Engelbart invented. They're still using an old-fashioned light pen, but it is a hypertext system that can be used to interlink documentation. Other similar systems from slightly later, the mid-70s, Carnegie Mellon did a bunch of work, and they came up with a system called ZOG that was later commercialized with another system called KNS. Why this is interesting is this is the sort of beginning of one style of hypertext. If you look back in the hypertext literature, people talk about card sharks and holy scrollers. The idea that a hypertext document should either be sized to fit within one display screen, so you can view the whole of a node at once, or whether it's something you should be able to scroll through. And ZOG was really the first of them to adopt this sort of card-based approach, whereby the chunking size of your hypertext has to be smaller than things that you can see at any one time. In terms of what it did, it's actually not that dissimilar to the web. So you have one-way links. The links are embedded in these frames, in these nodes. So in those terms, it's really fairly simple. It was only intended as a sort of single machine hypertext, so it's not distributed. And even the commercialized version, which came along a few years later, doesn't try and do that, although you will note that it does let you do things like view documents side by side, so you can do some comparison, visual comparison. Actually, no, it's all like KMS was distributed across a LAN. Other things KMS introduced, scripting languages. So all of a sudden, you could have some sort of programmatic behavior within your hypertext. So it's not just following linked static pages. Other systems around the same time. Ben Schneiderman, the chap who invented, who's done an awful lot of work in human-computer interaction research in the mid-80s, was researching in this area at the University of Maryland. His system, Hypertize, in some areas it's a little bit cruder than the web, so you could have links, but links only pointed to entire documents. There was no way to target a link to a part within a document. But it did have this notion of a link preview, which is a little bit like the alt text that you get in the web. So the idea here we have a document, here we have a bunch of links, either cards, note cards, tabletops. Here we have a link that has been selected but not activated. So we've not yet followed the link, but in the process of selecting this link, brings up a blurb, a brief description of the thing that's at the other end of that link. Try before you buy, try before you click. Brown carried on from the work they've done on solving KMS. We have Intermedia, which adds graphics, which adds bidirectional linking, so you can now follow things in both directions. Another very key system that had quite a big, not a direct effect, but a very big indirect on the industry, with note cards. Now, I've mentioned a few points, Xerox Palo Alto Research Center. So this is part of the Xerox Corporation who make photocopiers, and in the early to mid-80s, they were very tied up with this idea of the paperless office. So for a company that's producing something like a photocopier, they were very far-sighted in that they'd actually look forward to what would happen when people weren't relying on paper documents. Other things that came out of Park at about the same time, Wi-Fi was a Park invention, Windows on computers, icons, menus, pointers. So the standard user interface that you use, whether you're using Linux or Mac OS or Windows, has its antecedents in work that was done at Xerox. So they very much determined all subsequent computer UIs. Now their system, Note Cards, again has this card-based approach, so the idea is you display something that fits within a discrete chunk. It gave a few more things on top of this, so you had a hierarchical browser, so for once you could see where you were within hypertext. So here is a sort of a map, an overview map of the hypertext as a whole that you can zoom in on, and within this you can see the documents and the links that exist between documents. It had graphics, it had again a programmable API, so we can do dynamic hypertexts. And in terms of how it looks, it's not too dissimilar from some of the later creations, but bearing in mind this is early 80s, this is really quite advanced. So here we have something where it's showing us 4 cards, 1 graphical, 3 non-graphical. Within these we've got links, or rather anchors, that we can then follow. There's another anchor up there. There is a browser that can show you both the context you're in, so it can give you a map of the hypertext, but also can show you your history. Now if you think about a web browser, the history mechanism you have there is a very simple stack. You can go forward in it or you can go backwards in it. Note Cards actually lets you see the sort of side journeys that you may have made during your browsing, so you actually get a much richer view of your history within the hypertext. Now for most people, their first introduction to hypertext would have come at some point in the late 80s until about 93, 94, with this thing, HyperCard. Long before there was OS 10, Mac OS, the operating system for Apple Macs, incorporated with it a thing called HyperCard, which was bundled with every new Mac from the Mac SE onwards. This was an editing environment and a viewing environment for creating what they called HyperCard stacks. So a stack was a set of cards, and what you could do with these is you could produce cards, you could have links, so you could define anchors within these things that could be graphical or textual. It has a programming language that actually lets it interact with the rest of the operating system. So what people ended up using HyperCard for was not just creating hypertext, but creating full applications. Has anyone here played the graphic adventure game Myst? Myst was written in HyperCard many, many, many years ago. Myst is a bit old hat now, but still kind of fun, I guess. Okay, so we've sort of jumped forward about 20 years here. There's a lot of development that happened during that period. At the late 80s, well, at the time of the late 80s, the situation was that there were lots of research groups doing hypertext research, and all of their systems were one of a kind, and there was a view that there was no consensus on what hypertext was about, there was no agreement on the right direction forward to take hypertext, there was nothing to do with interoperability. So effectively, even though some of these systems were distributed over a LAN, the notion of a global hypertext, along the lines that Nelson conceptualized with Xanadu, was something that just wasn't being looked at. And at this point, there are a couple of very influential papers. So the first of these is a review article by Jeff Conklin that was published in IEEE Computer, so the main computer science journal that's produced by IEEE, in which he tried to do a number of things. He firstly tried to explain to people that hadn't come across it before what hypertext was, and then he looked forward to see what types of hypertext systems out there were. So we have another definition of hypertext. What is it? Windows on the screen associated with objects in a database. Links are provided between these objects both graphically as labeled icons and in the database as pointers. I'm not sure if I've ever used the word database in describing hypertext, to be honest. But a definition very much of its time, particularly because of the mention of objects, the gratuitous mention of objects. He identified 4 main families of hypertext systems at this point. So those which he referred to as the macro-literary systems. So these are ones in which it's an entire working environment that you produce documents in, you comment on them, you annotate them, and so on. So Memex, which never existed, falls into that category. Nelson's Xanadu, which was never completed, fits into that category. Doug Engelbart's MLS and Augment fit into that category. These are intended to be all-encompassing systems which support your daily work. There are some systems, and this is very much Jeff talking about his own research at the time, which are intended for things like problem exploration. Now you could look at these things and think these are sort of the antecedents of the mind mapping tools that you see around now, but a little bit more sophisticated. So the idea here is that these are tools that you could use for outlining, these are tools that you could use for problem solving, so talking about the constraints in the problem, talking about how those interact with each other. So his systems, IBIS and later GIBIS, allow you to take fragments of text, produce links between them, and have those links be typed. So the idea here is that you could use the typed links here to record an argument or a discussion, so that you could then record why certain decisions have been taken. And this is very much why he talks about these as problem exploration. There are some systems which were primarily used for readers. So they're not intended for people writing or creating things, but they're intended for publishing. So Zolk, KMS, Hypertise, all of these fall into that category. And in fact, if you look at things like Hypertise for a long time was used for things like tourist information systems. What restaurants are there in this town? What's the opening time of the museum? So the idea here is that the critical thing is speed of access. We want to get information to people quickly, but we don't want them to be able to change things. So this is the main difference between these and the macro-literary systems. And the final group he had was what he just called general hypertext technology. And these systems are the none of the aboves. They are general purpose systems that were predominantly designed, with the exception of Hess, to let people experiment with hypertext. Intermedia certainly fell into that camp, note cards fell into that camp. So you can use these to create applications, you can use them both for reading, for writing, and for collaboration. And he talked about what he considered to be the essence of hypertext. So there are some things that we know about these, and I've talked about this before, so I'll skim over this briefly. What's the point of hypertext? We have nodes, so we chunk our information into little repurposable bits. We have links, and there are a whole bunch of considerations for these. So how fast are links to resolve? Are they unidirectional? Are they bidirectional? Do we associate names, properties, bits of metadata with our links? Do they point to a particular region, or do they point to a node as a whole? How do links appear? What are their display characteristics? And he then talks about how hypertexts are organised. So do you build a hypertext so that it's a tree structure, or is it just a sort of loose network? Do you let people pass around collections of links, of link bases? Do you have the notion of a composite, a node that contains a bunch of other nodes through transclusion or some other approach? And he talks about the idea of history mechanisms, how those should work. Trails, going back to Bush's Memex, the idea that you could give somebody a guided tour through a hypertext, or you could provide them with a guided tour. And talks about the authoring process and the reading process and how those are separated from each other. Now, one of the notions he came up with in this paper, up until this point, most people in the hypertext research community were pretty resolutely upbeat about hypertext, although it was starting to become recognised that there were drawbacks. Hypertext was not a cure-all, it wasn't a panacea. So one of the notions that he talked about is this notion of being lost in hyperspace. You're reading a hypertext, and you get to a point and you can't remember how you got there, you don't know where you are, and you're not sure which direction you want to go in to find the thing that you're looking for. And in particular, the act of reading hypertext, unlike the sorts of things that Bush had talked about, when Bush says that hypertext works like the brain, hypertext actually imposes a higher cognitive overhead on the reader because they're having to make decisions about what they read next, which will take them out of the flow of reading. So those two notions, in fact, I mean, as for Lost in Hyperspace, how many of you have read the TV Tropes website at any point? Yeah. How long do you tend to read it at any one given sitting? I mean, or Wikipedia for that matter. I mean, for these sorts of sites, it's easy to go in looking for something and then sort of get sidetracked, and then an hour's gone past and you've forgotten what you were looking for.
Something like TV tropes are usually very long, something very specific, like, but something like Wikipedia are much worse, and I find, oh, that looks interesting, oh, that looks interesting too, and then I'm 5 pages in with the version you just had.
And that's exactly the Lost in Hyperspace notion. Partly because you don't have this idea of where you sit within the hypertext as a whole. Okay, so we've got Conklin's work. Another person, slightly later, Frank Hallas, who was originally one of the members of the note cards team at Xerox, wrote a paper for Communications of the ACM, which is the main ACM journal, in which he effectively wrote a roadmap for the future of hypertext. 7 issues for the next generation of hypermedia. And these are quite interesting because this is really the first time that anybody had sat down, apart from Nelson, and tried to write out everything they thought the hypertext system should have. Now, the sorts of issues he was talking about, Conklin had talked about the difficulties of being lost in hyperspace. That issue of being lost in hyperspace basically gives the lie to the idea that browsing is always the right way to find things. And this notion of browsing being the right way to find things goes back to Push pretty much. So, in addition to browsing, following links, link navigation, we need to be able to search for specific things. It might be just content search, find me things with this word in. It might be structural search. Find me things with these words in that link to documents with these words in. So some sort of structural search that allows us to search the link structure of the hypertext. Composites. Up to this point, most of the hypertext systems had the notion was you had nodes, you have links, and that's it. And here's the point: is that there are some places where you want to talk about a group of links or a group of nodes or a collection of both of them as a single entity. How do you talk about those things? So here is a node that contains synopses of all of the episodes of the X-Files, where each of those episodes of the X-Files actually has a synopsis in a separate node. Can you bring them all together into one place? Virtual structures. Now, some of these ideas are sort of there in embryonic form when you look at systems like note cards, which have a programmatic API. So the idea here is that there are some pages which aren't static pages. They're pages that are constructed on the fly as the result of the user asking a query. Other bits and pieces, computation over hypermedia networks. So when he talks about this, it's very much when you go to a particular node, when you follow a link, do we want some sort of side effect to happen? So following this link does something else in your computer. Also within this, can we do computation over the networks themselves? Can we build algorithms that scan through the networks to do things that tell us more about a hypertext? So you could very much argue that things like Google and PageRank are in this rough area. Versioning, as I said, versioning is a natural feature of operating systems that got lost with DOS. I don't agree with that. Versioning was in VMS, but Unix never really had it, so I think he's showing his history there. But the point here is that just as we can do file-based versioning across a hypertext becomes a lot harder because we have so many different entities that are interlinked. Let's say I have a page that links to another page, and there is a link that goes to a specific section. If this page changes, so the endpoint of that link is now no longer valid, what do I do with the link? Do I throw it away? Do I try and update the endpoint here? So some really thorny difficulties, which I'll talk about later in the course. Collaboration and extensibility. So can you let people work together? Can you change what the hypertext system does so you can build different things on top of it? And as papers go, as a clarion call, this was pretty well received. Jump forward a couple of years later to 91, at the annual Hypertext conference, he gave a keynote which looked back at those 7 issues. And by this point, most of the papers in the intervening time were making some reference back to his roadmap, back to his 7 issues. And he looked back and said, well, actually, we have those 7 issues. Here are 4 more ones that I think we should consider. Note the date, 1991, just after Berners-Lee come up with the idea of the web. So, the new issues. So the first of these is rather a difficult one to explain at this point. It'll make more sense in a few weeks' time when I talk about non-navigational hypertext. There have been some people, predominantly at Xerox, who were playing around with hypertext systems where the links were not links that you'd put on text, but the links were implicit in the way that you'd sort of put bits of document together. So if you think about this, let's say, let's use an analogy. If you're working on your, let's say you're working on your desk, you've got a desk full of paper, you would put sort of, documents that are related to each other in a pile, or maybe there's your to-do list which you've organised so you can see the things that you need to do, or the documents you need to reply to. One of the other hypertexts that have media data models is the notion of spatial hypertext, whereby the links that exist between documents are implicit in their spatial juxtaposition. So, for example, if I have a pile of related documents, clearly there's something that connects those things together. Now, I may not have explicitly told the computer what connects those things together, but it should implicitly be able to work out that there's some commonality between them, and that is taken to be a link of sorts. So his point here is that links should not necessarily just be the sort of click on this thing, navigable link that was the norm up to this point. Other types of hypertext should be possible. The second notion, he says, the monolithic hypermedia system of the 1980s is no longer a viable species. His exclamation mark, not mine. As I said, during the 60s, 70s, 80s, there were lots of people building hypermedia systems, but they didn't work together. Intermediate data would look different from Notepass's data, and so on. And so there was a whole research thread that led on from this, where people were trying to build open hypermedia systems. How can we enable different hypertext systems to share nodes, to share links between them? And some of this was looking at how you can take a hypertext system and decompose it into separate components. The bit that manages the nodes, the bit that manages the links, the bit that inserts links into nodes at the right places, and so on. And a lot of this community concerned itself with things like what were the protocols for communication, what were the formats for expressing links, for expressing nodes, and so on. And quite a lot of this work happened here at Southampton. Les was tangentially involved with it. Dave Millard, who some of you may have met so far, was on the working group, as in fact was Hugh Davies, who's on the Open Hypermedia group. Another piece, now this goes back to sort of Conklin. When we're dealing with a large hypertext system, it's not enough just to have a node-level view of it. We need to see the hypertext as a whole. We need to be able to manipulate the hypertext as a whole. So this goes somewhere around this lost in hypertext notion, but also looks at how we might apply this to editing. It's not just about reading, it's about manipulating. Now, lots of the previous systems had some sort of network browser, some sort of overview. They didn't always work well, but this was a recognition that things like this were needed in general and that this was a suitable area for research. The final one of his issues, which I think is the most comical, we need to be looking at very large hypertext. And in this keynote, he actually explained what he meant by a very large hypertext. Things that contain tens or maybe even 100s of thousands of documents. Can you conceive of a hypertext that big? Actually, quite easily. The point here is that all of these little systems that people have built with very small hypertexts. Hundreds of nodes, not larger. So the idea that you might use a hypertext system for managing a much larger collection of documents is quite problematic. And this was basically saying we need to worry about the sorts of tools that we give people, scalability of the underlying system. And as he said here, the challenge, a usable industrial strength hypertext system capable of handling 10,000 pages. I think you'll find there are an awful lot of websites out there by themselves which have probably hundreds of thousands of pages. Something like Wikipedia has tens of millions of pages on it. As I say, this was a keynote that was given in 1991. So, the web happens. Now in 1990, the year before he gave that keynote, there were three new hypertext systems that made their first appearance. And I'll talk a little bit about these in a future week. The web. The web is the one we all know of. Hyper-G, which was created at the Technical University of Graz in Austria. Microcosm, which was created here in Southampton. If you look at these three things, they all do very slightly different things. Microcosm, as originally envisaged, was a single machine system. Later expanded to something that would work over a LAN. It was never intended to be a global hypertext system, but in terms of the way it handled linking, there are some interesting features of it. Hyper-G, on the other hand, was intended to be something that would work at least at the enterprise level, and could also work at a global level. And in terms of how it organises hypertext, it's actually got a very rich underlying model. If we look at the three of them and look at Halaz's 7 issues, these are presented roughly in sort of ascending order of the degree in which they address Halaz's 7 issues, and also descending order of their uptake. Microcosm is virtually unknown and doesn't really exist in use anymore. Hyper-G turned into a content management system. The web is everywhere. Final slide, or penultimate slide. Bear in mind the keynote he gave where he talked about hundreds of thousands of documents. His challenge was a system with tens of thousands of documents in. This is not a graph of the number of documents on the web. This is the graph of the number of websites on the web. He gave his talk in 1991, which is about the point that the web got properly released. By 92, you had about 10 sites. By about 93, about 100. By 94, about 1,000. And you have this sort of period of exponential growth that lasts well into the late 90s before it starts to slow. Now, bearing in mind, each one of these websites could have easily hundreds of pages behind it, and you realise that actually the web is the thing that realised his vision of scalability, his vision of a very large hypertext. We look at where it is at the moment. So 2015, I haven't put the 2016 figures into this, about 1 billion websites. And each of those websites could easily contain thousands of documents. So trillions of documents overall. Yeah.
Is there any chances that the tech bubble sort of affected that graph?
Well, yeah, that is a very good point, because if you look here, so the dot-com boom would have happened within that sort of window, and clearly there's an inflection point in the graph at about that point. Or that point maybe very slightly earlier, because you can see a slight shallowing at this point. I think it probably did affect it. It's probably affected it better. If you look at where it is now, actually you're still seeing exponential growth, but with a longer doubling time. But as I say, this sort of data can be quite misleading. I mean, this is counting the number of web servers, which doesn't necessarily tell you something about the number of users. And bearing in mind when Netcraft do this survey, basically the Netcraft data runs from about 2000 onwards. The earlier data I've reconstructed from another data set. They keep track of the difference between the number of websites that are actively serving documents and the number of and the total number of websites. So the active ones are the ones that aren't just sort of resting pages saying this domain is for sale, for example. It's an interesting question though. Did the .com boom affect this? Are you going to write about that for your report? Okay. Let's complete the circle. We're at the last slide. So, this is a module about the architecture of the web. And this pair of lectures I've spent talking about things that aren't the web. The reason for this is I want to show you that the notion of the web didn't come from nowhere, that it's got very strong antecedents that go back through computerized systems into the 60s, and arguably go back earlier in terms of knowledge organization systems and knowledge management systems. When we look at the things that make the web what it is, it really comes down to the three fundamental technologies. And these are things that most of these predecessor systems just didn't have. A global system of identifiers to identify things, resources, nodes, what have you. Now, some of these other systems, some of these predecessors, did have global identifiers. Xanadu was designed with global identifiers in mind, never finished. Most of the other systems, you had identifiers that they would only be valid within a local context, say on a LAN or on a particular machine. The web was designed from the ground up to be distributed, with a clear separation between what the server was expected to do and what the client was expected to do. Compare that to a lot of previous systems where, for whatever reasons, the communication between different components of the hypertext system was done at a local machine level only. So the idea of distributing this over the internet just didn't happen. Finally, rather than trying to incorporate lots of other previous document formats, a simple markup language that people can write things in. Now, some of the previous systems just assumed that you'd be dealing with plain text. Well, that's great, but that doesn't actually give you very much. Others, like Microcosm, assumed that we'd be wanting to put links into all of our existing documents, whether they be Word files, Excel spreadsheets, what have you. The web decided not to do that. This is simple language that we have that you can use to write structured documents. And it provides a very low barrier to entry. All you need to do to write a client is something that can understand this markup language and give even a half-baked rendering on the screen. I used to say that, one thing I would say here, if you look at the beginning of the web, in terms of these three technologies, there's not very much there. Any competent software engineer should be able to write an okay-ish web browser in a couple of days. And that probably led a lot to the early growth in the web, because it had a very low barrier to entry. If we look at some of the other systems, like Hyper-G, they're far more complex in terms of their protocol. Some of the others are far more complex in terms of the types of documents that are supported. So the web really hit the sweet spot in terms of simplicity, unlike the complexities of many of the hypertext systems that existed before. Okay, any quick questions? Right, let you all go. One thing I would say, if you look on the module website, there's quite a lot of reading material there. Now, the reading material that I've got down here is mainly down here to support what you do in your reports. You know, I'm not saying this should be an exhaustive list of things that you must cite, but take this as a jumping off point for doing your research. Most of the things that I've cited in my presentation, I've got links to papers here. There are some things that I really do encourage you to watch because they're just plain fun. The Hyperland documentary is really, really fun. It's very silly in places, but it gives you a good view of what people considered hypertext to be like before the web came along. Okay, thank you very much. I think I've got you. I've got you for 2 days next week. And what I'll be doing is I'll be looking at non-encyclopedic hypertext. I'll be looking at narrative hypertext, or hypertext narrative.
那个